Example 39.5. If the bag contains 13 marbles numbered from 1 to 13, how many unique selections of 3 marbles are there? When I see this problem, I think about the key phrase, how many, and that phrase, how many, makes me think of a counting technique. And generally speaking, I usually think about two methods. I think of fundamental counting rule and combinations. And I always try to see if it's combinations first because that's usually easy to eliminate. And I know if I can't eliminate it, then I should use it. So let's start with combinations. In order for something to be combinations, there has to be a set that we want to draw a subset from. Do we have a set of things that we want to take a smaller subset from? Well, let's see. There is a set of marbles from 1 to 13, right, with numbers 1 to 13 on them. There's 13 marbles and they're numbered. So that's my set, and I want to select 3 marbles from there. It sounds like I have a set of things and I want to draw a subset from it. So that sounds good. That meets the combination rule requirement. The only other thing I have to check to see is if order matters in the problem. Is there any indication that order makes a difference? It says how many unique selections of 3 marbles are there. So in other words, it seems to me they're not saying that I have to worry about what order they come out in. So imagine if I got the marbles 2, 1, 3. Just imagine that. Say the marbles came out, it would be 2, marble 1 and marble 3. Say those come out of the bag for me. Isn't that the same as saying I drew the marbles 1, 2, 3? It's the same marbles being chosen, right? So it's the same group of 3 marbles. So I don't think the order matters here. There's no indication in the problem that we should worry about the order. Because of that, I'm going to assume it's combinations, and then we can do the problem using that rule. So with combinations, what we do is we try to fill in this formula, right? NCR or NCX, depending on what variable you want to use here. It doesn't really make that much of a difference because what we're thinking of is out of a set of 13 things, we want to choose 3 of them. So that's all we have to do. So it doesn't matter what symbol you use here, whether it's R or X, it's still 13 choose 3 in the end. And to work that out is pretty simple. We take the first number, put it on top, factorial. We take the second number and put it on bottom, factorial. And then we take the difference between these two. So 13 take away 3 is 10, and we put that on the bottom, factorial. And then from there, we just kind of extend this one out. We do 13 times 12 times 11 times 10 factorial. And we stop as soon as we see the same thing at the bottom. And then I'll do 3 times 2 times 1 times the 10 factorial. And because everything is multiplied here, I can cancel. And once I've done that, I then can just simplify this with my calculator, or I can do some reduction first. For example, all of this makes 6, right? So all of this cancels with 12, leaving 2, because 6 goes into 12 2 times. So I end up with 13 times 11, or I could even say, 26 times 11? It's time to maybe show a little trick with 11s here. When you're multiplying a 2-digit number by 11, you can actually use this little trick. Put a space between the 2 digits and then add them together. 2 plus 6 makes 8. Your answer is 286. Just in case you don't trust me, whip out your calculators and you'll see that that is indeed the correct answer. That trick works with 11s for 2-digit numbers. All right.